Hello again. We're still practicing balancing reactions or half reactions in acidic media. So at this point, having done three of them, I'm going to assume that you know the steps pretty well. So buckle up. I'm going to go through these kind of rapidly, and probably just a bunch of reps is all you need to get comfortable with this now. So first one, we have one story that's about arsenic, another story that's about bromine. So we'll split those up. ASO3, 3 minus. ASO4. And we have a story with bromate. Minus. Do not lose little signs like this. A lot of the time when people mess up one of these questions is because some ion has a -1 charge, and that little line gets left behind when they're copying something, and because of that they get their charge wrong, they get their electrons wrong, and it just breaks everything that comes after it. So don't let that happen to you. Arsenic is 1:1 here, bromine is 1:1 here, so that step's okay. 3 oxygens, 4 oxygens, left side needs an oxygen. 3 oxygens, no oxygen, right side needs an oxygen. Needs 3 oxygens, sorry. 2 hydrogen, need 2 on the right. 6 hydrogen, needs 6 on the left. Charge, -3 and -1. Right side's higher, right side needs 2 electrons. And +5 versus -1, left is higher by 6, so left side needs 6 electrons. Need to match our electrons. The lowest common multiple for 2 and 6 is 6, so we triple the whole first reaction. 3 times this, 3 times water, 3 times whatever that is. 3 times 2 is 6, and 3 times 2 is 6. Now that that's all sorted, we can cancel electrons. Coincidentally, we have 3 water in each one, so we can cancel those. And this is very unusual. We can actually cancel all of our hydrogens. Not often do you get that much cancellation, but hey, we'll take it. Makes the finished reaction easy. I didn't give myself a whole lot of room here, but our finished reaction is going to be 3 of the ASO3s. And a bromate. Arrow, 3 ASO4s. And a bromide. Note to self, write a little smaller on the next ones. Good? Okay, let's create a little more space and try that a few more times. Okay, so here we have one story about phosphorus, another about iodine. HPO3, that's the hydrogen phosphite ion. Turns into the dihydrogen phosphate ion. And elemental iodine, or molecular iodine, turns into iodine ions. 1 phosphorus, good. 2 iodine, 1 iodine, not good. We need a coefficient of 2 here to get that sorted. And now we do our oxygen, hydrogen, and so on. 3 oxygens, 4 oxygens, left side needs 1. No oxygen, good, no action required. 3 hydrogen, only 2 hydrogen, right side needs a hydrogen ion. No hydrogen, cool. And charge, we have -2 on the left. -1 plus 1 is 0, so 0 on the right. Right side needs to be dragged down, it gets 2 electrons. And here, total charge 0, total charge -2, left side needs 2 electrons. This iodine reaction is in the data book, if I remember correctly, so you could confirm this one if you wanted to. But certainly you want to be able to do it yourself. Okay, lucky us, our electrons already match, so no need to change anything or no multiplying required. We just mash these 2 reactions together, and of course we can cancel our electrons. So, HPO3 minus plus an iodine plus, oh, sorry, I skipped over the H2O, so I'll put it in now. I try to do these in the order that I read them, but that didn't quite happen today. And H2PO4 minus plus H plus plus 2 iodine ions. Good. Onward. Okay, here we have a story about iodine. That's the iodate ion turning into elemental iodine. And then we have sulfur dioxide turning into sulfate ions. All right. One iodine, two iodines, not good. Fixed. One sulfur, good. Oxygen is next. How many oxygens are here? Don't say 3. There's 6, right? 2 IO3s is a total of 6 oxygens. So the right side needs 6 oxygens, which come in the form of water. 2 sulfur versus 4 sulfur. Left side needs help. Needs 2 oxygen helps. Hydrogen, none, 12. And here, 4 hydrogen, no hydrogen. Right side needs hydrogens. And charge. Plus 12 minus 2, total of 10 charge, total of 0 charge. So we drag down the high side by giving it electrons. And here we have 0 charge, and what is that? Negative 2 plus 4 is positive 2. The right side is higher. The right side gets 2 electrons. Quick note, these are redox reactions, meaning one side is getting reduced, one side is getting oxidized. That always means there should be one side where you're gaining electrons and one side where you're losing them. So here, having electrons on the left in one of these half reactions and on the right in the other is basically mandatory. If you ever have electrons on the left in both reactions or on the right in both reactions, that's no good. Something's wrong. That would be like a financial transaction where you say, I paid her $10 and she says, I paid him $10. You should hear that and think, wait, those can't be right. One of you should be receiving money that the other one gives. So this left and right thing is a good sign when you see that, and it's a bad sign if you don't. Okay, we want to combine these, and we can't now because why? The electrons don't match. We have 10 electrons in our first reaction, only 2 in the second one, so if we quintuple the second reaction, we get 5 times that. 5 times 2 is 10 water. We get 5 times sulfate. I'm trying to make my 5s and my s's look different. 5 times 4 is 20 hydrogen, and 5 times 2 is 10 electrons. Now that the electrons match, we can cancel them out. Anything else we can cancel? Hope you said yes. 12 hydrogen here, 20 here. We can lose 12 hydrogen from each side, so these are all gone. And 12 of these are gone. 20 minus 12 leaves us 8 hydrogen. Anything else we can cancel? Say yes. Good. We have water on both sides. 10 here, 6 here. We can remove 6 water from each side. So these are all gone. And 10 minus 6 leaves us 4 water on the left. With all that done, our total is 2 iodates. And that's all gone. 5 sulfur dioxides. Arrow. Iodine. And... oh, I'm sorry. I missed something. You see what it is? This is the risk of getting too scribbly here. I have 4 H2Os on the left, and I almost missed them because I was scratching out my own writing. That's a consequence of not leaving myself enough room. Don't let that happen to you. Iodine plus 5 sulfates and 8 hydrogen ions. Good? Two more and we're done. Hope you're getting comfortable with this. It is the same steps over and over, and the math isn't that hard, I don't think. Okay, we have a nitrogen story and we have an iodine story. So NO turns into nitric acid. This could be hydrogen nitrate, or it could be nitric acid. I don't know the states. And H5IO6. I'm not even going to try to name that. And HIO3 is probably iodic acid. Okay, nitrogens, 1 and 1, good. Iodines, 1 and 1, good. I should make my eyes look the same. So with those balanced, we look at oxygen, 1 oxygen, 3 oxygen. Left side needs 2 oxygens. 6 oxygen, only 3. Right side needs 3 oxygens. Hydrogen, 4 on the left, only 1 on the right. Right side needs 3 hydrogens. 5 hydrogen, what is this? 6 plus 1 is 7 hydrogen. 5 versus 7, the left side needs 2. There, now it's 7 to 7. And now we come to charge. No charge, plus 3 charge, so the right side is higher. We drag it down with electrons. Plus 2 charge versus 0 charge. Left side is higher. Left side needs 2 electrons. Okay, we want to add these, but what's the problem? Our electrons don't match. And they don't match in a tricky way this time. We have 3 in the first reaction, 2 in the second. Lowest common multiple for that is 6. So we need to get both of these to 6 electrons. For the first reaction, that means double everything. 2 times 2 is 4. 2 times that. 2 times 3 is 6. And 2 times 3 is 6. For this reaction to get to 6, we triple everything. So 3 of that thing. 3 times 2 is 6. 3 times 2 is 6. 3 iodic acid. And 3 times 3 is 9. Okay, can we cancel anything? Water. We have water on both sides. 4 up here, 9 down here, so we can lose 4 water from each side. Those are all gone, and 9 minus, you know what, I'm going to do this nicer. 9 minus 4 is 5. I'm going to actually erase this just so there's a little bit less mess. We'll see if we can avoid what bit me last time. And for hydrogen, lucky, 6 and 6. It's nice when that happens. And of course our electrons cancel. We planned that. So, finished reaction, 2 nitrogen monoxides and 3 H5IO6 on the right, 2 nitric acid and 3 iodic acid and 5 water. How you doing? One more? One more and we should be pretty great at this. Okay, we have a carbon reaction and we have a manganese reaction. H2C2O2 is 2 carbon dioxide and permanganate. Spoiler alert, this permanganate reaction is in the data book, and we've done it before, so you'll recognize what happens with this one, maybe. Okay, carbons. 2 on the left, 1 on the right. Unacceptable. Must fix. Manganese. 1 on the left, 1 on the right. Good. Oxygens. 2 versus 4. Left side needs more oxygen. 4 oxygens versus none at all. Right side needs oxygen. Hydrogen. 4 here plus another 2 makes 6. Right side has none. Right side needs 6 hydrogen. And no hydrogen at all, 8 hydrogen. Left side needs 8. And charge. No charge at all, plus 6 charge. Right side needs 6, or needs to lose 6, I should say. And here, 8 hydrogen minus 1 from this means a total of plus 7. This side is only plus 2, so this side is higher by 5. We drag it down with 5 electrons. And this is the reaction that, half reaction that you'll see in the data book if you look. So we want to combine these. 5 electrons and 6 electrons. What's the lowest common multiple for that? 30. Yikes. Biggest number we've seen by quite a bit, but that's okay. Big numbers don't scare us. We're chemists. So we need to make 30 electrons here. We multiply all of this by 5. 5 of this thing. 5 times 2 is 10 water. 5 times 2 is 10 carbon dioxide. 5 times 6 is 30 hydrogen. 5 times 6 is 30 electrons. And down here we multiply everything by 6. 6 permanganate. 6 times 8 is 48 hydrogen. 6 times 5 is 30 electrons. 6 manganese ions, and 6 times 4 is 24 water. Now we're ready to combine these, but let's do our canceling first. What can we get rid of? The electrons, of course. 30 electrons before and after. That is by design. We have 30 hydrogen here and 48 here, so we can lose 30 hydrogens on each side. Those are all gone. 48 minus 30 will leave 18 hydrogen on the left. And for water, 10 water, 24 water, we can lose 10 from each side. So these 10 are completely gone, and 24 minus 10 leaves 14 water. And with that, we add for the last time 5 H2C2O2, H2C2O2 plus 6 permanganate ions plus 18 hydrogen ions. Sorry for the line break, but the solutions are in the way. 10 carbon dioxide plus 6 manganese 2 ions plus 14 water. And that's how you balance half reactions and reactions in an acidic medium. I hope you enjoyed it. We don't cover basic media anymore in this course. You might see mention of that in the notes. If there is, it's safe to ignore it. If you're really curious about it, ask the instructor and they can show you how it works. It's only, basically you do all the stuff we've just done and then one more step at the end. So they're not even all that hard. But you don't need it, so don't burden your head if you don't need to. See you in the next thing.